Okay, ma'am. I'm audible too, right?
Yes, yes, ma'am.
Okay, ma'am. Okay. Thank you, ma'am. Thanks for the welcome. And first of all, I would like to thank Pencil Bits team for giving me such an opportunity to express my insights on LangChain topic. Let me start the session without any short delay. So myself, Kritika, and today we are going to see the topic on LangChain. Before starting that, let me start with the quote. A future of education is not just about what we teach, but how we teach it, with the AI paving the way of personalized learning experience. I hope you believe with this quote. When we see in the long days and all, whenever we have any doubt or query to be sorted out, we'll be referring only the book. At some point of time, it has been changed, and the doubts what we have will be referred only through Google. Now the entire era has been changed. So all the thing what we are having as a doubt is being approached through ChatGPT and Google only. So this is the two thing which own the world in these days. And one more thing before starting that, let me start with a thing called knowing the value of. That is the question. So imagine that there is a bank which deposits 86,400 rupees in our account daily in the morning. The condition is that at the end of the day, you have to utilize that entire amount. So that amount cannot be transferred to the next day. You cannot save the amount. We cannot give it to anyone else. Only we have to utilize that. Next day, next day morning, the same amount will be credited to our account. So if there is a bank like that, so how our life will be? That's nothing but time. So every day we have 86,400 seconds in our life. The day starts with this second. So we have to utilize that seconds throughout the day. And we cannot carry forward this time to next day and we cannot go back also. The time given is there at present in our hands. So we have to utilize that. So we have, suppose you want to know the value of 1 year means we have to ask a person, ask a student who got failed in that particular year. To know the value of 1 month, we have to ask a mother who have given birth to a premature baby. To know the value of 1 week, we have to ask a magazine reporter who publishes article every week. And to know the value of 1 day, ask a person who born on February 29. To know the value of 1 hour, ask a lover who waits for his or her pair. To know the value of 1 minute, ask the person who missed the train in just a minute. To know the value of 1 second, ask a person who just escaped from a major accident. To know the value of 1 millisecond, so ask the athlete who secured the silver medal. So only he knows the value of 1 millisecond. So the time which is given to us is very, very precious. So we have to utilize that effectively. So with this, let us dive into AI topic. And do you think AI is going to replace the human? Actually, some experts said that AI won't replace humans, but replace humans without AI. So humans with AI will replace human without AI. So we have to be much updated to get it replaced. Otherwise, we'll be replaced by someone else who knows AI. And there are some eras which have crossed the path. So 1980s is called as a computer revolution. So while companies like Microsoft were more focused on software, their work significantly influenced hardware development by setting standards and driving demand. In contrast, companies like Apple, HP, Dell, and Cisco were directly involved in creating and innovating hardware that shaped the personal and professional computing landscape of the 1980s. Next comes Internet Revolution, which is the period of 2000s. The Internet revolution of the 2000s was characterized by the emergence of companies that not only provided new services but also fundamentally changed how people interacted with technology. Google enhanced information access, Facebook redefined social networking, Amazon pioneered e-commerce and cloud computing, YouTube transformed video sharing. These innovations set the stage for the further evolution of the internet and digital culture in the years to follow. Next comes mobile revolution, the period of 2010s. The mobile revolution of the 2010s saw the rise of apps and platforms that reshaped communication, entertainment, and social interaction. Twitter redefined real-time communication. WhatsApp became a dominant messaging platform. Spotify revolutionized music streaming, and ShareChat catered to regional needs. These developments underscored the increasing importance of mobile technology in everyday life and set the stage for further innovations in the digital era. So now, the biggest of all, it is AI revolution. The AI revolution is at a pivotal function, similar to transformative tech shifts of the 1980s, 2000s, and 2010s. It shares the aspects of foundational changes, disruptive innovations, and rapid growth seen in these past eras. But it also presents unique challenges and opportunities due to its broad and deep impact across industries and its ethical implications. As with past evolutions, the current AI era is setting the stage for significant future developments. Now, let's delve into the topic of LLM, a cornerstone of modern in artificial intelligence. Before knowing about LangChain, let's see about LLM. Large language model is a typical artificial intelligence designed to understand, generate, and manipulate human language. Essentially, these models are complex algorithms trained on extensive text data to predict and generate human-like text. The word large in this large language model indicates the model's extensive scale, both in terms of volume of the text data it is trained on and the number of parameters it uses. Models are not just about generating text. They are equipped with to perform a variety of NLP tasks such as summarization, language translation, and sentiment analysis. Suppose you are given with a very big paragraph, and this NLP will summarize the core content out of that big paragraph. Sometimes we need to translate some content from one language to other language. That is also made possible with NLP. And sentiment analysis. So this is knowing the emotion of the sentence. So giving a sentence and knowing the emotion of the sentence is also an important task nowadays. So it is also a part of NLP task. And this NLP task is all performed through LLM. Let's know how this LLM works. Real-time large language models require an immense amount of text data to perform effectively. To gather this data, they often rely on internet or web crawlers that extract information from numerous websites, providing a diverse array of text. While this data is vast, it may vary in quality as it includes content from a wide range of resources. The data that has been fetched from all these web crawlers is enormous, but the quality is very less because the website's content will not be always an exact one. Some websites will be having some valid data and some will not be having the valid data, but web scroller doesn't bother about all these things. It just extracts the data blindly from all the websites. Initial training phase, that is, this phase is called as pre-training. It helps to build a foundational understanding of the language. Models are trained using deep learning and artificial intelligence networks, which allow them to learn complex language patterns. The primary task of this LLMs is to predict the next word in a sequence, which is crucial for generating coherent and contextually appropriate text. Continuing with the LLM work, a transformer architecture, which is the backbone of creating large language model, enabling them to process and generate human-like text with remarkable efficiency. In the realm of AI, there is a distinction between general AI and generative AI. While traditional AI might provide answers based on pre-existing data, generative AI, like ChatGPT and all, not only answers questions but also generates new dynamic content based on its training. ChatGPT exemplifies a generative AI model that analyzes input and creates contextually relevant responses. Accuracy and effectiveness of these models are measured by their data volume and the number of parameters they use. For instance, GPT 3.5 boasts an 175 billion parameters, which contributes to its capability but also demands substantial computational resources, including significant processing time and GPU power. Creating a large language model, it involves two main steps. First one, during pre-training, the model learns to predict the next word in a sequence based on vast amount of text data. This foundational training builds the model ability to understand and generate human-like text. Next, fine-tuning. So this step focuses on improving the model's performance and presentation skills. This involves validating the data and adjusting the model based on the specific requirements. In this phase, the process includes manually feeding questions and answers to refine the model further, preparing a specialized data sheet, and retraining the model with its targeted input. While this step uses less data compared to pre-training, prioritizes higher quality and relevance, leading to quicker and more efficient adjustments. The goal of fine-tuning is to reduce the need for extensive manual adjustments in the future, thereby streamlining the model's performance and making it more effective in real-world applications. Pre-training takes more quantity of data will be more there, but quality will be less compared to fine tuning. So here it is quality will be more where the quantity is very less, because for fine we are getting the data from pre-training step. So pre-training does all the work. It extracts the relevant data and give it back to fine tuning. So it is the reason why it is getting less quantity of data, and it needs only less time to do that one. So when you see about the examples of ChatGPT 3.54 and all, so launching these models, LLMs might have taken big amount of time because it has to construct everything from the scratch. So it needs a large amount of time. Once it is launched, for fine tuning, it takes only less amount of time. That is called as the second step, fine tuning. Now, let's get into our main topic. What is LangChain and why we use this LangChain? LangChain is an open source tool that enables the development and deployment of large scale language models by providing a framework for integrating and interacting with LLM environment. So this open source tool is being developed with Python programming language. A notable example is ChatGPT. Here, allow it to process and generate human-like response. So after feeding the response, it generates the text as like us. So as I said, example for this is ChatGPT, a trending AI tool, which exemplifies how these tools can produce coherent answers based on the training data. However, it is important to note that while ChatGPT can handle a wide range of queries, it is limited to responding to questions based on the data it has been trained on and may not effectively address unknown programs, codes, or novel questions beyond its training scope. So ChatGPT works on only the training data. So when you're asking questions beyond that, it cannot answer all those questions. And about LangChain use. So why we use LangChain means it is a powerful tool in the world of large language model, offering capabilities that surpass many traditional methods in handling and processing language. Its design emphasizes ease of use, allowing users to leverage its features without needing an in-depth understanding of its underlying mechanics. LangChain is also highly extensible, enabling developers to integrate their own chains and agents within its framework, thus customizing and expanding its functionality. Additionally, its flexibility makes it a versatile solution for building a wide variety of applications, from simple text analysis to complex interactive systems. accommodates diverse needs and use cases in the realm of AI and language processing. Here, let's see pictorially why we need LangChain. So here is an application. The first picture what you are seeing is ChatGPT. So when you're using ChatGPT as an application, it internally makes a call to OpenAI API. So which internally uses the LLMs GPT 3.5 and 4. So in this picture, the first picture is ChatGPT, but it's just an application. It is not an LLM. An LLM. So this application calls OpenAI. In turn it calls GPT 3.5 and 4. GPT 3.5 and 4 is called as LLM, and ChatGPT is just an application. So we are going. So in our session today, we are going to create an application as like ChatGPT, which is going to call OpenAI, and in at the back, it is going to call GPT 3.5 and 4. There are some limitations in using this architecture. So as I said, ChatGPT is just an application which calls OpenAI API, which in turn again calls LLM. And this architecture has some limitations. Everyone cannot use it. So when you see in recently nowadays, so there is a big boom in the industry that every business wants to build their own LLM. Why can't they use ChatGPT? They can't use ChatGPT because ChatGPT can't access your internal data. So ChatGPT has its own data, but it has no rights to access our own private data. And also, they cannot build their application. And the business peoples, they want to build their own application based on this LLM. So, though ChatGPT is a popular one, suppose I want to build an application for my own company means, so I cannot rely on ChatGPT because so ChatGPT can't access my data. Apart from that, there are some limitations to create an application with OpenAI. The first barrier is the cost. Suppose you want to use OpenAI API key means, so it has some cost associated with it. So we have to pay some dollars to access OpenAI for our personal use. So it is not affordable all the time. The next barrier is real-time knowledge. So as we know that ChatGPT is trained on some pre-built data. So the updated data is available only till September 2023. So you cannot access real-time data through this open AI. That is also not possible. And third barrier is ChatGPT cannot access our private data. So only we know. Suppose I'm having a business, I'm having a company name, so it cannot access my employees' details. It is not possible for ChatGPT to access the data of my company. So you don't have access to private data. So these limitations are there to access this OpenAI. Suppose a company want to create an application for its own means, it cannot rely on OpenAI since because it is associated with some cost, and we cannot ChatGPT cannot access the real-time knowledge, and it have no access to access our private data. So what is the solution for this means? Suppose I want to create an application for my own. So you need to say you want to create some applications for your own means you need some framework. So your application is going to you need to call this OpenAI, and suppose you don't want to use OpenAI since it is deal with cost association. You don't want to use OpenAI means you can go for some open source tools like Hugging Face, Bloom, many more things are there like that. So if that can be replaced with OpenAI. In case you want to create an application for your own company means either if you are able to pay money, you can access OpenAI. Otherwise, you can access the open source tools like Hugging Face and Bloom and all. And you need some framework to connect your application and this OpenAI Hugging Face also. And that framework should also give plugin support to access these models. This framework should also provide integration with Google Search, Wikipedia, and also integration with your own organization databases so that the application pull data from all these resources. that is OpenAI, Google, Wikipedia, your own database. So there should be some framework which connects all these things. So hope you get what I'm saying, trying to say here. Suppose you want to create an application, and through that application, you want to connect, you want to pull the data from OpenAI or Hugging Face, and you want to access the data from Google, Wikipedia, and your own database also. So you need some framework in between to connect all these things. That framework is LangChain. So this framework easily helps us to pull the data from OpenAI as well as the general search engines as well as your database. That is the picture where this LangChain comes in. So OpenAI API alone is not enough to build an app based on LLM. You need also the framework like LangChain to build an application for your own. So there are some modules available in LangChain to build an application. So they are models, memory, prompt, chain, and then agent. Let us see about all these modules one by one briefly. The first module is models. So in LangChain, model component serves as a unified interface for interacting with large language models, abstracting their complexities involved in their use. It simplifies the integration process by providing a consistent way to work with different models like GPT-3, 4, and others, regardless of their underlying specifics. These components offer flexibility by allowing users to easily switch between various models or versions based on their needs. Models module supports a range of natural language processing tasks, including text generation, summarization, translation, and provide options for customizing how these models are utilized. Essentially, the model component acts as the bridge between the application and LLMs, facilitating efficient and versatile deployment of these advanced tools. Nowadays, tech companies have produced several LLMs on their own. So to see that, Google company creates its own LLM, which is Lambda, BERT, Form. Likewise, OpenAI company creates a language models like ChatGPT, GPT-3, 3.5, 4. Likewise, Meta AI company also creates its own LLM, Llama. So these are the models developed by these companies. See an example coding for creating a model in LangChain. So first we have to import the library, which is Google Generative AI. So in our example, we are going to connect with Google Generative AI because since OpenAI is a cost-effective one, so I have used in my coding the key of Google's. And so you have to import this Google Generative AI class from the LangChain. The package name is LangChain Google Gen AI. You have to install that package. Later, from that, you can import this Google Generative AI. And then you have to import the operating system module. After that, using os.environment method, you can set the Google API key, which is required for authentication. So each of the models, suppose you are choosing OpenAI means so that generates an OpenAI key. Hugging Face has its own API key. So each of the model has its own API key to connect with that. Here, since we are going to use Google, the Google API key is to be fetched from the Google website, and that is going to be used in our program. Then you have to generate a model. So creating instance of Google Generative AI by specifying the model name. Here the model name mentioned is Gemini Pro and the temperature parameter which controls the creativity of the response. So this Google Generative AI function, it takes two main parameters, model and temperature. So model represents what model you are going to use in your program, and temperature is the float value which varies from 0.0 to 1.0. So when the value is getting increased, the response that you get from ChatGPT will be of a random one. When the temperature value is very less, it displays you a discriminative values. So based on the temperature value you are giving here, the response will be varying in your in the output. Then you have to call the invoke method on the LLM instance with the prompt. What is your name? It is given here like that. So this method sends the prompt to the model and returns the generated responses. Finally, we can execute the generated response through the print statement. This is a simple way of modeling the module in LangChain. And then comes the next module, it's memory. So they typically run in unintended mode by default, meaning they autonomously handle tasks without needing constant user intervention. This makes them ideal for applications like chatbots and other automated systems. In LangChain, memory component is crucial for managing and maintaining context over interaction with large language models. This component ensures that the system can remember and utilize past interaction to provide coherent and contextually relevant responses. Here, it has two types of memory, which is short-term and long-term. Short-term memory focus on storing information relevant to the current session or interaction, ensuring that the system can maintain a coherent flow of conversation and respond appropriately to recent queries. This type of memory is essential for keeping track of the immediate context and details within a single session, such as remembering a user's recent question and answers to provide relevant and continuous responses. On the other hand, we have long-term memory. So it is designed to retain information across multiple sessions, allowing the system to build a more personalized experience over time. This memory, this memory type stores historical interactions, user preferences, and specific details that persist beyond individual sessions, enabling the system to offer tailored response based on accumulated knowledge. Memory is an important thing needed in LangChain. There are types of memory implementations designed to handle different aspects of context management and interaction history. The first one is summary memory. It captures and retains concise summaries of past interactions, focusing on key points rather than every detail. This approach is ideal for applications where a high-level overview is sufficient, helping maintain context without storing existing data. For example, For example, a chatbot might use summary memory to recall the main topics discussed in previous sessions without needing to store every individual message. The next type is buffer memory. It stores previous messages in sequential logs, allowing the system to track and reference the exact flow of conversation. This is particularly useful for maintaining continuity and accurately addressing user queries by reviewing the entire message history. For example, customer support systems may use buffer memory to review the entire chat history to address users' queries accurately. Then comes the next type. It is sequence to sequence memory. This memory organizes the conversation history in a structured sequence, enhancing the model's ability to understand and generate responses based on the progression of the dialogue. This type is especially beneficial for complex multi-turn conversations where understanding the sequence of interactions is crucial. Here's an example to create memory in LangChain. So first we have to import the class. So the class name is chat message history, which comes under the package langchain.memory. So it is after importing, so after installing that, so we have to import from langchain.memory module, which provides the functionality for managing the chat message history. Then we have to create a message history instance, which is assigned to a variable h. This instance will be used to store and manage the chat messages. Then comes user message. The add user message function is called with the string whatever we are giving in our scenario. This will add a message from the user to the chat history. Then comes AI's message. The add AI message function is called with the string welcome. The content is given there to add a response from AI to the chat history. Here, user message and AI are communicators. User message is the message what we are giving to the AI, and AI is the what it is returning back to the user. This chat has been created, and after receiving these messages, it is accessed to retrieve and display the results in the stream. Next comes another important module in LangChain, which is prompt. So in LangChain, the prompt module plays a critical role in crafting and managing prompts that guide interactions with large language models. This module helps in defining and customizing the inputs that are fed to the LLMs to achieve desired output. The prompt module is designed to facilitate the creation, management, and optimization of prompts used to interact with LLMs. It ensures that the prompts are well structured and tailored to elicit accurate, relevant, and contextually appropriate responses from the modules. Here is some key points to be key features of prompt. First feature is prompt templates. It allows users to define templates for prompts that can be reused and customized as needed. These templates often include placeholders that can be dynamically filled in with specific details or variables. For example, you can create a template for a question answering system where the template is used to insert different questions dynamically. We can see the example of this in our coding part. And next feature is the prompt management. This provides tools for managing and organizing various prompts, including saving, retrieving, and updating prompt configuration. This is useful for applications that requires a range of prompts or different styles of interaction, which helps in maintaining consistency and accessibility of prompt configuration. Next comes prompt optimization. This offers techniques and strategies for optimizing prompts to improve the quality of responses from the LLMs. This feature also includes adjusting prompt phrasing, structure, and content based on feedback or performance. Example, refining prompts to reduce ambiguity and increase specificity can lead to more accurate responses. That is also one of the features of this prompt. Last feature is dynamic prompting. So this allows prompts to be generated or adjusted dynamically based on the context of the conversation or application requirements. This prompting is useful for interactive systems where the prompt needs to adapt in real time based on the user's inputs or evolving scenarios. Here is a coding example of prompt. As usual, we have to import the module LangChain and the class name prompt template, and whatever query we are going to ask, that can be given to the parameter to the variable temp. My favorite programming language is name. The name is given inside the flower bracket, so this is the call as a placeholder. And later, prompt template function, it takes many parameters. The most important things are two things. One is input variables, and next one is template. The input variable is the placeholder what we are given in the previous line. So that and this should be same. So this is the placeholder to be given. The next parameter is template. So giving a template to display the text. So after finding the template and the content, we have to convert it to a formatting string, which is using the format function. And this Python is the input variable what you're passing to our program. This Python will be replaced in the place of name variable, name placeholder, and the output will be my favorite programming language is Python. So this is a prompt which is given by the user. And next module, chain. Chain is also an important part of LangChain. In LangChain, this chain module is the fundamental component designed for creating and managing sequence of operations or tasks involving large language models and other components. Chains enable the orchestration of complex workflows by connecting multiple steps, each performing a specific function. Ma'am, now am I audible? Is there any interruption? Okay. Shall I continue, ma'am? Okay, fine. So chain enable the orchestration of complex workflows by connecting multiple steps, each performing a specific function. So these are some specific functions of the chain. The first one is sequential execution. Chain executes a series of steps in a specific order. Each step can involve interacting with an LLM, performing data processing and other operations. This sequential execution is useful for tasks that require multiple stages, such as data extraction, transformation, and response generation. For example, you might use a chain to first gather user input, then process this input, and finally generate a response based on the processed information. Next comes integration of components. Here, the chains can integrate various components, including LLMs, prompt templates, memory systems, and external data sources. By combining all these components, chains can handle uh, uh, complex tasks that involves multiple types of interaction. For example, a chain might use a prompt template to generate a query, retrieve data from a database, and then use that as an LLM to interpret and summarize the result. Next task is input and output management. Each chain has defined inputs and outputs, allowing the flow of data through the sequence. The output of one step often serves as the input for the next one. This feature ensures smooth data transition and allows for complex workflows. For example, the output from a data extraction step can be fed into a processing step, and the result can then be used for generating the final response. Next important task is modular and reusable. Chains can be designed as a modular component that can be reused or combined with other chains to build more complex workflows. Chains can be designed as modular components that can be reused or combined further. Then comes an example for the chain. So creating a chain, the first step is after importing the packages and classes and all. So the third step. So here you are importing the class later to change the LLM chain. So initially you have to first you have to generate the API key, then you have to create the prompt. Only then the third main step is only creating the chain. So for that you need to import the LLM chain class, which is under the package langchain.chains. After that, you have to create an generative, that is API key is to be connected. This is the done step done previously. And then you have to create the prompt template as usual and to process creation. So here the chain is created, taking the LLM instance and then a prompt template as an argument. So this chain will use the provided prompt to generate the response based on the input given by the user. Here the input given is Mexican. So based on the input, it gives the results. Next, I think the final module, it is agent. In LangChain, this agent module is designed to handle dynamic and autonomous interactions with large language models, that is LLMs, and other components. Agents are capable of making decisions, managing conversations, and performing complex tasks based on contextual information. It also has some features. The first one is autonomous operations. Agents operate independently to handle the tasks and queries. They can make decisions about how to process inputs and manage interactions without requiring constant human intervention. This is particularly useful for applications like chatbots, virtual assistants, or any systems where continuous and context-aware interactions are needed. Dynamic decision making. Agents are dynamically decided how to route or process information based on the current context and state. They can choose different actions or responses based on user input or other conditions. Context management. Agents are designed to maintain and utilize contextual information throughout the interactions. This includes remembering previous exchanges and using this context to inform current responses. For example, an agent in a customer support system can recall previous interactions with the user to offer more tailored assistance. Next component is integration with other components. Here, agents can work with other LangChain components such as chain, memory, prompt, and all these things to build more complex workflows and interactions. For instance, an agent might use a chain to process user input, interact with the database in the backend, and it generates responses based on results acquired. Last important component is customization and configuration. Here, agents can be customized and configured to fit specific use cases and requirements. Includes define how they handle different types of inputs, manage context, and perform actions. Here is an example of creating an agent. So the class name is agent and the package name is langchain.agent. And in this coding, we have used OpenAI that can be replaced with, as I said, it can be replaced with either Google API key or with Hugging Face or anything else like that. And as usual, after creating the model, we have to define a function for agent's action. This is all a Python program. And after that, you have to create an instance for the agent and then use the agent to handle the query and you can print the response. So this is a simple and sample coding to generate agent in our program. So moving on. So far we have seen what is a LangChain and what is LLM. One more thing is also there which confuses us here, which is chatbot. So let us see a differentiation of what is a chatbot, LLM and LangChain, where all these things differ. We'll start with chatbot. The chatbot is a software application which is designed to simulate conversation with human users either through a text or voice interaction. Whereas LLM is a AI model trained on large amounts of text data to understand and generate human-like text based on the patterns learned during the training. Whereas LangChain, it is a framework designed to simplify the development of applications that uses LLMs. It helps developers build and manage complex workflows involving LLMs and other data sources. Next difference between all these three things is in chatbot, it handles customer service tasks, provides information, or assists with various users' queries. LLM, so it can perform a wide range of language related tasks such as answering the questions to the user and generating the text based on the queries given by the user and then translating the languages and many more. So it has a broad understanding of language and the context. LangChain, so this provides tools for interacting language models with external data, managing conversation, and creating sophisticated AI-driven applications. It supports tasks like chaining together multiple LLM calls, handling structured data, and managing context. Next difference to be shown here is in ChatGPT, often ChatGPT is integrated into websites, messaging apps, and customer support system. whereas LLM is used as the core technology for chatbots, virtual assistants, code generation, summarization, and other language processing tasks. LangChain, it is a typically used it is typically used by developers to create advanced applications that leverage the capabilities of LLMs, such as interactive chatbots, data-driven applications, or systems that require complex reasoning. It is all done in the LangChain. Let us see an example of each of this one by one separately now. First, we'll start with chatbot. So let us see an example for chatbot. So let us see a customer service chatbot. Here the scenario is you are visiting an e-commerce website and you have a question about your order status. The role of chatbot here is when you interact with the chatbot embedded on the website, you type in your question. What is the status of my order? Chatbot uses a predefined set of rules and scripts to understand the query which is given by us and responds with the information about the order status. It pulls the data from e-commerce platforms database. It also provides options to track your shipment or contact customer support if needed. So all these data will be pre-trained in the databases. So based on the query you're using there in the chatbot, it fetches the data from the website database and then it gives back to the user. So this is the role of a chatbot. Let us see some applications of chatbot. The first one is customer support. A customer service chatbot on an e-commerce website helps users track their orders, resolve issues, answer frequently asked questions. For example, a bot might handle questions like, where is my order? Or if you want to know, how can I return an item? So these questions can be answered by the chatbot in customer support. When you see about healthcare assistance, a healthcare chatbot provides patient about symptoms, appointments, and appointment scheduling, and then medication reminders. So all this data can be stored in the database and it works as a chatbot. Example, so healthcare assistant bot might help user to find the information about flu symptoms, or suppose you want to book a virtual consultation with the doctor, that can also be done with the help of health assistance chatbot. Next application is travel and booking. So when you see a chatbot related to travel and booking, so this assists users with booking the flights, hotels, rental cars, like that. To provide travel recommendation also, answering queries about booking policies and booking confirmations. Whatever you want to deal with travel and booking, so this data will be stored in the database and that will be fetched by created exclusively for travel and booking. Next application is HR and recruitment. So here is HR chatbot. It automates the initial stages of recruitment, answering the job seekers' questions and then scheduling interviews, providing information about company policies. So likewise, the chatbot can be created exclusively based on the user's request and then the company's response based on that. Next, we'll here the example we can see for LMS text generation for creating creative writing. Let's take a scenario. So you are working on a writing, when you are working to write a novel, which needs help, which needs a brainstorming idea for a plot twist. Here, the LLM used to give service like OpenAI to create a creative writing prompt or suggestion based on the problem they have. So your input is a brief description of your current model for ideas or unexpected flow language. Processes your input and it generates several creative suggestions that you can consider incorporating into your story. So based on the key points and keywords in the LLMs, generate the text dynamically and creatively based on the input or given by the user. So this is the work of LLM. Whereas in chatbot, it has a pre-trained data. The question asked will be fixed only from the pre-trained data. You cannot answer beyond that. Ma'am, am I audible? So next we'll see the applications of LLM. LLM is used for content creation. LLMs like GPT-4 can generate articles, blogs, posts, or marketing copy based on given prompts. For example, a content marketing team might use an LLM to draft a blog spot on industry trends or social media content. Next application is virtual assistants. So virtual assistants like OpenAI's ChatGPT, it helps the users with variety of tasks such as drafting emails and then generating creative writing and then providing summaries of long documents. These are all can be done as LLM applications. Then about language translation, LLMs are used in translation services to provide real-time translation of text or speech. For instance, tools like Google Translate use these large language models to translate the content between different languages. And one more application for LLM, it is research and summarization. It can be used to summarize academic papers, research reports, and even news articles. It provides concise summaries or extracting key information. Researchers and professionals can use these summaries to quickly grasp the main points of lengthy documents. So these are some of the examples of LLM's application. Then our comes our main picture, which is LangChain. So here the example what we have taken for LangChain is intelligent personal assistant. And scenario for LangChain is suppose you want to build a sophisticated personal assistant that can manage various tasks like scheduling meetings, answering questions, and retrieving specific information from documents. Here, the LangChain uses the framework LangChain framework is being used here to develop this assistant. LangChain helps you to create a workflow where the LLM can interact with various data sources. For example, so when you ask the assistant to find a document related to a specific project, LangChain manages the process of retrieving the document from a database, understanding its content and summarizing it for you. It also chains together different actions such as scheduling a meeting by interacting with your calendar and confirming availability through assistant's conversational interface. So LangChain is built upon multiple LLMs. This is an application. Some of the applications of LangChain is complex workflow automation. A LangChain can be used to create a comprehensive customer support system that integrates multiple data sources and services. For example, it can manage a workflow where an LLMs handle user queries and then retrieves from a database and at last performs additional tasks like scheduling follow-up actions. Next application for LangChain is data-driven applications. Here, LangChain can power applications that combine LLMs with structured data. For example, an application might use LangChain to build an intelligent data analysis tool that requires a database process that requires a database, and then it processes the result using an LLM and then presents actionable insights to users. Next example we can see for LangChain, which is enhanced conversational agents. So here, in this case, LangChain can be used to develop advanced conversational agents that interact with users, access external APIs, and manage multi-turn conversation. For instance, a virtual assistant built with LangChain might handle complex customer inquiries by retrieving information from multiple sources and generating detailed responses. We'll see one more application for LangChain, interactive knowledge base. LangChain can create interactive knowledge base that leverage LLMs to provide users with accurate information from extensive document collection. For example, an, uh, an internal knowledge base for a company might use LangChain to allow employees to ask detailed questions about company's policies and procedures and then retrieving and summarizing the relevant documents in response. So these are some of the applications of LangChain. So to the whole, so chatbot is like an one-to-one communication conversation based on the pre-trained data, and LLMs is one step ahead of chatbot, which creates an interactive and creative content based on the user's input. And LangChain is the one which builds on multiple LLMs together. Now, we'll recollect some core concepts and components of the slang chain. So far, we have seen some modules and all. So out of those, so we'll see very important core components. So which is chain and then agent, memory, and then prompts. So these are very important components compared to other. So in our live demo program that we are going to see in the next to this presentation, so we are going to use chain and then prompt in our program. So these two are very much important while doing the LangChain programs. Now I think presentation is over. So let us dive into the LangChain application creation. Let us see a live demo for creating the application using LangChain. So to getting started with that, first you have to install few packages to work with LangChain. The first one is you have to install LangChain, and then so since in our coding we are going to use Google's GenAI API key, which is of free source. Actually, I tried with OpenAI; it is a cost-effective one, and I tried with Olama model and all, which acquires more RAM capacity. So I find this to be the best one compared to other things. So I have chosen Google's GenAI, and then you need to use a Streamlit package, which is extensively used as an interface. So the backend coding we are going to do using Python only, and then as an interface we are going to use this Streamlit. So you have to install these three packages to work with the program, and then you need to install Python also. So I have used Anaconda software. So through that I have launched a Jupyter notebook. So from there only I'm going to do my Python program. So it is up to you. So choose any Python platform. Many sources are available. So choose any software which you are comfortable with, and then install all these packages so in your system. So as I said, you need some form of Python to store this Python file. These are the prerequisites to do programs using LangChain. And here, so in our application, we are going to build an architecture. So where LangChain is the main core, uh, is the framework that we are going to use. And then we are going to use Google's GenAI API key. We are going to connect with Google. So as I said, so when you are typing some query, that is our application. When you type some query, that will be going to fetch an Open API key. OpenAI API key. Here we are going to use Google. So this in turn at the back, it is going to retrieve the data from GPT 3.5 and 4. That is all done in the back, at the back. So our task is we are going to create an application which in turn is going to call an Google's GenAI API, which in turn is going to call back GPT 3.5 or 4 at the back. And then, so in our coding, to do this process, we are going to use two main modules of LangChain. One is prompt template and other one is chain. So we are going to use only two things. So prompt template is used to give the prompt to the user. And then these prompts are going to be connected with chain. This is the work which is done in the LangChain part. And then after doing all these things, after creating connectivity with Google and then generating the coding, everything else is done. At later part, we are going to use Streamlit as an interface to show it back to the user. This is the structure we are going to design in our live demo now. Let's start with Let me show you some coding demo. So let's get into the Jupyter notebook. So let me create a folder. So after getting into it, create a new notebook. So I'm giving the file name as demo. So first step is, first you have to install the packages, LangChain, and then whichever I have given there, Streamlit, and then LangChain, Google Gen AI. I have installed all these packages already in my system. So suppose you want to work with LangChain means to install these packages using the command pip. Give pip install LangChain in the command prompt and then install all those things in your system. So after installing, the first thing is you have to import the OS module. So I'm giving import OS, and then as it is said, you have to give the environment variable environ, and this is like a dictionary object which takes key and value. So key which you are going to give is Google underscore API underscore key, the key, and the value you have to get it from the Google website. So actually I have taken and stored in my system. So you can get this key from Google website. So let me copy it and paste it here. Fine. So now I have generated the API key which is already created. The next step is, let us see a simple example. So from already I've installed all these things. So LangChain, as we have seen in the PPT. So LangChain underscore Google underscore Gen AI is the module. From there, you have to import the class, import Google Generative AI. And then you have to build the LLM model, giving it as LLM equal to same. Go.
Ma'am? Hello, ma'am. Ma'am, it is audible? Ma'am? Ma'am, it is audible, ma'am? Ma'am, it is audible, ma'am.
Extremely sorry, I got disconnected. Let me connect it once again. Let me open the Jupyter notebook to execute our long chain program. Already we have created a Google's API key is being uptime, and with the help of that, we have imported an OS module to connect our application with Google API. And then we have started with an example of displaying a simple content. Very slow. This is what we have created. Have to import the operating system module to connect our application with Google's API key. And then we have given a simple question to ask the GPT. So here we have asked that question as what is your name? See, our application has called the Google API key intern, and that intern has called GPT 3.5 or 4 something else, and it has given the answer as I am a large language model trained by Google. Likewise, now we are going to create an application. So what our application is going to be is we are going to display some state's name. So when you select the state name, our application is going to generate some name for my portal for the specific state. And then it will give a name for restaurant. And in turn, so in the first chain, we are going to select the state name. And for that state, yes, it is going to generate a name for the restaurant. This is going to be the first chain. In second chain, we are going to give some menu items for that particular restaurant. This is what the application we are going to create in LLM now. So let me give the next prompt. So again, it is going to be the same lang chain and generating this. Let me copy the first two lines. It is going to be same. And after that, so we are going to generate restaurant name. So I'm giving it as a list name, which is a variable. And then invoke the LLM model. So there, inside the bracket, you give the question to be asked. That is, I'm giving it as, so I'm planning to open a restaurant in Tamil Nadu. That highlights the region unique flavor. So can you suggest a catchy name for it? I've given a question and then print this variable rest name. So I'm asking the application to generate a name for my restaurant, which is going to be, this was the name generated by PT for a restaurant in Tamil Nadu. So in case I'm changing this as Kerala, now it gives some different answers. Screen is not visible. So now is it visible, ma'am? Oh, okay. So this is what we have done. So hope you have seen this. The First, we have imported the class Generative AI from Google. So from the module LangChain Google Gen AI. So this step already we have seen. So we have asked the query as what is your name to Google. So it is generating the name of that model. This is a LLM model trained by Google. So likewise, now we are going to generate an application which is going to give us a name for a specific state and also menu items for that particular restaurant. That is what we are going to create. So these two lines are same. So only the last two lines we are going to change based on our query. So here I have given the query as, so I am planning to open restaurant in Kerala that highlights the region's unique flavor. And then can you suggest some name? So can you suggest one catchy name? So likewise, I'm asking it and then I'm printing it. So it is giving a name like that. Suppose I am changing the state name as some other name. It is Karnataka. So it is giving some other restaurant name for the state Karnataka. So here, this is a simple program in LangChain. Now what we are going to do is we are going to generate a prompt. So here each time so in this question, so we are changing this state name each time. Instead of changing the state name in the coding itself, we are going to generate that as a prompt. So for that, what we are going to do is here, let us take the same coding. I don't want to modify that itself, it will be confusing. Let us take these two lines as it is. Now we are going to create a prompt. So for creating the prompt, you need to import the specific module and then the class name. So it is from LangChain dot prompts is the module. And then from there, we are going to import the class prompt templates. So after importing these things, then is we have to generate a prompt. So for that, so let me give the variable name as prompt template name, and it calls the function prompt template. This takes two parameters. So first is going to be input variable. So this is a parameter name for prompt template. Input variables, and here you are going to give a placeholder which is going to be state, and second parameter is a template. So many parameters are there for this prompt template function. Here we are going to use only two. The first one is input variable and the next one is template. So template, what we can do is we can take the same question. So like, am I audible? Can you see the screen now?
Yes, ma'am.
Okay. Okay. Okay, so I've copied this question, this query, what I've given in the previous step. Just I'm pasting it here. So double quotes is to be closed. Okay, here, so in the place of this is going to change each and every time. So that I am replacing with the placeholder, which is state. So you can see here. So each time when to change directly the query, so we are going to use prompt. So based on the prompt, what we are passing here, the question will be responded there. So for this, we are using prompt template, which takes two parameters, input variable and then template. Input variable is to be given as within a square bracket. We have to mention this, mention the input variable name. And this is to be given as the placeholder in the template. So here with the flower bracket. Now the prompt is created. Then you have to display it convert it to a format string. I'm giving it as p equal to this one, from template name. This name, and then within bracket, mention that input variable name, state, and you can give the value here. You can give any name. So I'm giving it as Andhra Pradesh. And then I'm printing it. Currently. And to get the output, you have to call the LLM model. So print LLM dot invoke this P. So this step is not needed. Yes. So I think this will work. You forgot a comma. So this has to be closed. Unexpected indent. One second, let me correct what mistake I have done. Just let me modify this. Prod template is not callable. Okay, actually, I don't want to waste your time. Let me take the coding which I have tried yesterday. Yes, actually, I forgot to give format. So this is the mistake I have given. So I have to use this prompt template dot format string is to be given. So only then that will be passed to the Okay. So now this is the prompt. As I said, after importing the Google's API key and then prompt template, after constructing the LLM model, so prompt template can be used here to generate the response each time based on the user's request. This is how you want to create a prompt. So next we'll see how to create a chain. So creating a chain. So now the task is that you're going to give the state name. So for the state, it is going to generate restaurant name for that particular state. And next chain is going to be, so for the restaurant name, it is going to generate the menu items. This is the sequence that you are going to do. First, we'll create it using a chain. Here, you want to import the package. Command chain dot chain. From there, I have to import the class LLM chain. And then go to LLM model and the prompt here. So I'm giving the variable name as chain, LLM chain, and it takes two parameters. First one is the LLM model. It's going to be LLM. And next one is going to be prompt, which is your plate name, which is given here. Yes. So chain is, as I said, chain is going to connect all these. It's going to connect the LLM model and then the prompt. So after connecting, then you have to invoke this chain dot invoke. Then you can mention the state name, that is input. So in case LLM chain is not working, you have to go for the next one. Module not prompt. Spelling mistake. Now duplicate. So you are giving the name state as LLM and the text is given like this. So due to the version problem, it is showing an error. Or else you can replace this with some other line. So it is chain equal to LLM and then pipe symbol and then prompt template. So based on the version, it will be changing.
Ma'am, it is audible, ma'am. Yeah, ma'am. Ma'am, it is audible, ma'am.
Ma'am, am I audible now?
Yes, ma'am, it is audible.
Okay, well, let me show the demo itself so that I can close the session because it is time up. So let me show the
Okay, okay.
demo of what I have shown, ma'am.
Okay.
So actually, after coding all these things, you have to create a Python file. You have to create two Python files. So let me open it. So or let me take the program what I have tried yesterday. So you have to, after coding it in Python, you have to actually create two Python files. See, the first file is this one. So I had to import the Google API key and then prompt template chain. Here we are going to use the chain, which is of, there are two types of chain. Here we are going to use sequential chain, which is going to connect two chains. And then as usual, you have to import the operating system module and then generate the module. Oh, screen is not visible. And is it visible now? And can you see the screen? Okay. Let me quickly show the output. Okay, I have generated a function. So where in this function, I have created two chains. The first chain is for generating the restaurant name. Second chain I have created for the menu items. So after creating the two chains, here I am using a sequential chain, connect name chain and then menu chain. These two things are connected using a sequential chain. This is going to be my first program. And the next I have to connect it to Streamlit. This is the main program. So Streamlit is an UA interface to execute this to the user. And then I'm importing the first program. This program name is FUNC. That is imported in my main program. All now. And then to give a title form Streamlit, I'm giving the name and then here. If we run it first, I'm saving this to Python files, and then I'm going to terminal. After going there, so my program is in code basics. So first to execute my program, I have to give string std string. Then I have to give the command run, and name of the file is home.py. So when I give this command prompt to the browser, so this is my output screen. So this framework connects our own application with OpenAI and then Google, Wikipedia, as it is shown in the PowerPoint. This sidebar. So here, when I am selecting the state name, it generates the output. So here the name of the restaurant is Malabar Post, and these are the items for that restaurant. And I am changing any name, giving it as so when I change the state name, it gives me the name for my state and also the menu item for the particular restaurant. So on local host, yes, okay. This is a simple landing application. So as I said, it is going to connect multiple alarms, Google's API, and then at the back end, Google search engine Wikipedia. This is the purpose of live. Since time is not available, I could not type live. I can give you the live coding here. So I've taken the previous the code which I have tried yesterday. So in case if you need in future, I'll share you the coding also if you want to work language and you want to import these packages as it is given language is needed, and then I have used Google API that import this package and then stream it for the interface. That's what I want to show it to you. So thank you all for listening patiently to what I have presented today. Thank you, Pencil Bits, for giving me a wonderful opportunity to have a recap about LangChain. So only because of you, I have read the topic. Thank you so much for that. Ma'am, shall we end the session, ma'am? Because I don't want to take much time after this.
Okay. Thank you so much for spending a valuable time with us. Thank you so much.
Okay.
I would like to thank all the participants who have attended 5 days on Generative AI. You will be receiving a certificate by 3 business days, and the feedback will be sent by today evening. You can get your certificate and materials recording everything in the attaching mail by the certificate. Thank you all. You can end it. Thank you.
Thank you.